I'm back. How do I sound?
Sound good?
Do I sound better?
Yes, much better.
Are you just saying that, or do I actually sound better?
No. You sound better.
Okay, you sound better. No, I mean you look good. I mean you look good. I mean you look fine.
No, I mean for you sound great. Yes, absolutely. I mean, what are our expectations here?
Right, look, we're late. Let's go. Get in the car. All right, fine.
Yeah.
Well, Dave, thanks for joining us.
Yeah, glad to be here. Long-time listener, usually on delay. First-time caller. I usually catch the YouTube recordings, but it's nice to actually be here.
Be here live. It's actually for a live recording, and I mean this Odyssey is extraordinary. That you and if folks haven't seen it, the gist from Dave will take you through this path. But Dave, maybe you could take it from the beginning of this thing. Like, where did all of this start? Because I feel it started like 6 months ago. Is that right?
Yeah, that's about right. I went back and looked, and it started while I was testing a different change to Omicron, which is our control plane. And I was running the test suite, and I just got a test flake failure, like a spurious failure, that was actually a different problem. Well, I don't know that it was a different root cause, but so I guess the background is in the let's see, our control plane uses CockroachDB very heavily. And so as part of our test suite, we spin up and spin down these transient instances of CockroachDB so that all these tests run in what they think is their own database with, clean slate and everything, which is great. Works great most of the time. So this happens probably like 160 times during a run of our test suite. And occasionally while running the test suite, and in this case, I found a case where a test failed because CockroachDB exited very shortly after it came up with this mysterious, it died on a Go runtime error from this illumos specific code calling port getin and getting enval from port getin, which is not really supposed to happen, right? Enval basically means you gave bad arguments to the syscall. And we spent a little while looking at the code, and it was not clear how that could happen.
And then, Dave, when you first saw this, you had this like initial urge, or maybe you don't, but certainly I had this initial urge to just like, can I unsee this? Like maybe this just didn't happen.
Yes, there is definitely that. It was, but there's also this urge that's like, if I run this again, I'm gonna see it again, right? I have to see this again. This can't just be the only time this has ever happened or going to happen, right? You know what I mean? You've had that experience as well.
Well, and how reproducible was this kind of out of the chute, where you're seeing these guys?
Well, so that's the thing. So then I started running the test suite in a loop, and I started running into all these other problems. So I was basically like, surely if I run this again, I'll see it again, right? There's nothing special about this one time that I ran it. I should also be clear that my change that I was actually testing had nothing apparently to do with anything in this neighborhood.
It always starts this way. Does it? Like, I've got this innocuous change. I just want to make sure that nothing breaks. Oh my God. Yep. Strange, crazy error message from the animal brain of the runtime.
Right.
And so it begins. Like, okay.
So then I run it again in a loop, and it's like different strange error from the internals of the runtime. And I feel like, there were a couple of phases to debugging this problem. And in this first phase, I was kicking off a lot of these loops of the test suite. And every couple of days or whatever, I would wind up getting a different panic from inside the Go runtime.
Oh, man.
Which was tough. and you're sitting... You're sitting there...
Several dimensions of tough.
Yes. Yep.
So what are some of those dimensions of tough?
Well, so one of the problems that I had, which I didn't really appreciate until I'd gotten pretty far along, was that my sort of bookkeeping of all these different failure modes was not very rigorous. So I would see, I'd see another bug and I'd file another bug sometimes. And if I saw another instance of one, I'd be like, oh, I guess that was another instance of this one I've already seen or whatever. And I wind up filing like 5 or 6 bugs. But as I've been working on this kind of in the background for a couple of months, I was kind of like, man, I kind of wish I had been a little bit more diligent about organizing these, because I wanted to ask questions like, we'd be blowing some assertion based on the number of things allocated. Not to jump too far ahead, but I want to know, like, is it the same size thing that we're dying on every time? And I
Yeah.
hadn't really collected that data very rigorously because I didn't know like this was going to be so hard to reproduce, or that there were going to be 4 or 5 different failure modes that were very close but not exactly the same.
So
Do you know what I
Yeah,
mean?
but
So
it should be said that your lack of rigor, your claimed lack of rigor, I think was like other folks on the team were bumping into this, right? Like every once in a while there would be some CI run and be like, well, that has nothing to do with this. And I think to some degree, and I don't think this necessarily speaks well of us, or maybe I'll just throw myself under the bus, speaks well of me, that you just say, okay, look, this is a flaky test that sometimes flakes, and that's bad. But, onward.
yeah,
And you had taken the time
The,
to catalog these.
the
it,
pretty
I-
serious. It's the pretty serious kind of flake, though.
it is, but this is shades of econ reset on running AK test, Adam. You remember this?
Absolutely.
And so at Fishworks, back in the day at Sun, where Adam, Dave, and I all worked together, we had a test suite, and there were these errors that would crop up every once in a while that were not that reproducible. And Dave's like, "What's going on with all these econ resets?" And I remember all of us was like, "I don't know." It's like Dave's like, "Isn't it serious? Is it like, don't we have a test suite so we understand the failures?" And and Dave, you spent a long time. I mean, this surely
I spent a long time on that one.
this issue must have reminded you of that issue at some level.
Sometimes
it is.
Sometimes it's network weather.
So it is very similar in that what was happening in that test suite was we had this management server, and we weren't restarting it, as I recall. That would run for the duration of the test suite, but we had hundreds or maybe thousands of tests that would spin up and make RPC calls against it. And very occasionally, like 3 or 4 of the tests would fail with this econ refused, I think it was.
It was
Maybe
econ
it was
refused.
econ reset.
No, I think you're right. I think you're right. I think it was econ refused. Yeah.
So it wasn't. It wasn't most of the time, but it was definitely enough that it was annoying, I think. Like if you were running this test suite as part of putting back a change, like there's a good chance you were going to run into this, and you would like rerun those tests and be like, okay, I guess it's fine. And it wasn't the same tests, so it was very hard to. It was very similar to this one in that it's very hard to develop the instrumentation you want because you have no idea when this is going to happen. So, yes, it is very similar.
Well, and
but one funny thing about this, I actually don't know that we were hitting this one in CI at all. I couldn't find any record of that, even from me. Like, I don't think I had seen it in CI and filed a bug. I saw this on my test machine. And a big theme of the debugging process for this one that is really not in the write-up, because I didn't get a chance to talk about all the blind alleys in the write-up, was which machines saw this or didn't, was kind of a big question for a long time. Like, are we only seeing this on AMD machines? Is there a reason for that? Is it Helios specific? We're not really sure about that. Had we ever seen it in CI and all that stuff?
And Helios is our illumos distribution, illumos born of Open Solaris, born of Solaris, just for folks who might not be familiar.
Right.
So you're seeing this, and you've rerun the test suite. Now you're seeing a bunch of new failures. And you're just like, oh, brother, I'm just trying to get this other change back. You know what I mean?
Right. Well, I think I satisfied myself. I did the thing where I reran the whole test suite, and there's no reason to suspect it was related. So I got that change back, and I kind of put this on the back. I mean, what I thought was I'll try to reproduce this by running it in the background. And going back to like what's tough about running into all these different failure modes is like it's easy to run into a failure mode and be like, okay, maybe I'll add some more instrumentation for this case. And then you run the loop again and you hit a different failure mode. And you're like, I have no more information about the thing that I wanted, and now I have a new problem.
Right.
And then repeat that, and then you're just like, it feels like you're spinning a little bit, because you are.
Yeah, so so then how do you proceed from there? How does it kind of unfold from there?
Let's see. I'm trying to remember what the prompt was, but I don't remember if I started hitting this again, but at some point, I think it was late October, I felt like part of my problem was the fact that I was doing this in the background. And so I wasn't really holding a lot of state about this problem. It could potentially be months before, before I would pick it up again. So I filed their first bug May 27th, going back and looking. This is bug 1130 in the Omicron repo.
Yeah.
And there would be sort of like spurts of activity. You know, Robert helped me debug that one for a little while. We found some interesting stuff about that one. I still, by the way, don't know for sure what was going on in that one. That's kind of one I want to come back to, because apparently I have a pathological need to debug CockroachDB memory corruption problems, even when I've got the other one figured out. But at some point I was just like, I need to focus on this and actually be more diligent and rigorous about the way, or at least about the way I spend time on it. So I started taking more careful notes and all this stuff. But at this point, I was still doing what I've been calling this sort of heuristic approach to debugging, which I think a lot of people are familiar with, which is where you're like, you know, this is the thing where you're like, well, what's changed? Or is there something common to the systems that are hitting it? Or is there something else that's like, feels like a promising lead? I keep thinking of them as leads, as, you know, it's like, you know, there's the detective analogy for debugging in general, but there's something especially like fuzzy about the idea that like, oh, I heard that this might be a problem in this area, so I'm going to go spend some time there. But there were so many of these possibilities that obviously all turned out to be blind alleys. And in retrospect, some of them were totally nonsensical. So for example, one of the first things I did was try to get, so I suspected memory corruption early on because the actual failure mode that I wrote about was blowing an assertion inside the Go runtime about the number of things that were allocated from this data structure. And it was definitely like, you know, I expected this to be 50 and it was 25 or something. It was like a very bizarre invariant violation in the memory subsystem. So I was like, well, if it's data corruption in memory, maybe I'll try libumem. I'll see if I can get libumem going. It's got all these tools for identifying these problems early. And now I know that libumem wasn't even on the scene. I mean, the system memory allocator was not even on the scene. Malloc wasn't there. So like all the time I spent on that, which is not a huge amount of time, but it's like that was just a waste because I didn't actually look at what was going on. And then similarly, you know, I can't remember if it's Go, I guess it's CockroachDB is using gmalloc. And so I got that test suite going to make sure, you know, to see if there was some problem with that on illumos that was causing corruption. And that was, you know, fine, but like these are shots in the dark, right? There was not a lot of strong evidence to indict any of those things. And I'm not sure if those were mistakes or not, but there were a lot of these. And the thing that really I felt helped a lot was when actually Robert gave me the kick I needed. You know, one of these blind alleys was whether this was AMD specific, and I started looking at AMD processor errata. And Robert helped me look through that, and he's like, I'm happy to help you do this. This is great. But this doesn't seem like a likely explanation based on the fact that you're seeing this on a couple of different generations, and it doesn't really feel like that. So, you know, maybe look at the error message. He said it a lot more nicely than that. But it was kind of like, why don't we look at this failure mode a little bit more deeply? And that's when I started actually digging into the code that was causing this in the Go memory allocator, which, you know, have you guys experienced this when you're debugging something where you're like kind of avoiding the big expensive step because you're hoping that there's going to be a cheaper thing that's going to turn out to show the answer?
I mean,
You know what
absolutely. Yeah, no, I mean it's like you're looking where the streetlight is instead of where we dropped our keys. Like I feel like it's an easy one.
Feels like optimizing. Really.
Yeah, you're like, I'm gonna check.
Yeah,
it is the streetlight file. It's like there's 15 streetlights over here, so I'm just gonna exhaustively check all those, even though the keys were dropped somewhere else.
Well, and in particular on this one, Dave, I think that the sort of hairy thing that you were avoiding was like imbibing this incredibly complex system of Go memory allocation.
That's exactly right.
Maybe not just because it was complicated, but also feeling like it, you know, the kind of risk reward. If you're like, if in order to debug this, I need to have a complete proficiency and fluency in this subsystem, then actually, like, I don't have those 6 months or 9 months or 12 months or whatever it's going to take to develop that level of fluency. So I better look elsewhere.
Yeah, and it is one of the hard things about a problem like this is figuring out which of these things is worth spending time on, right? I think you described it at some point as a balance of, as probability of success for each of these. But ultimately, I think that was probably the best way to get where I got.
So
I mean, I guess you could argue differently, but that's how it felt for me.
So Robert is here. Robert, when you were having that discussion with Dave, I mean, Dave is saying that you phrased it very nicely, but that you, as he's asking you for errata details, are you how are you vectoring him in a different direction?
Well, I think the biggest thing is that the biggest challenge is that while, as Dave was saying, we're kind of looking across both Zen 1, 2, and 3, so 3 different microarchitectures. And it's not that erratum don't go from generation to generation that don't exist, but that more often than not, they're at least, if it's that bad, it's that bad. On the other hand, the biggest problem with erratum is that they're often even worse to pin down because, as the vendors like to say, a complex series of microarchitectural steps occurred. Like what? And they're like, I don't know. Like, you tell us. And that's kind of all you get. So the biggest challenge with that is just, and I think the reason I probably looked towards the actual error message was trying to understand how could we work backwards from the final cause of death to what might lead up to that to help.
Yeah, and especially when you do have fatal failure, you really do need to say, why are we dying? We've got we are doing something that ultimately the microprocessor is forbidding us from doing, and in this case, we're ultimately doing well. There are several different manifestations of it, Dave, but ultimately we're doing an errant memory operation effectively, and starting to work backwards. So, Dave, it sounds like that's what you started down that path.
Yeah, and yes, absolutely. And even then, it took a while, and there were a lot more blind alleys in that direction. I learned a lot about Go. I've still only written 30 lines of Go, maybe, in my life, and most of those for this problem. But I know quite a lot about the Go runtime now, the way the memory allocator works and stuff.
It's a familiar feeling.
Yeah, I feel
like I've become an associate member in this club that a bunch of you were already in, and with more senior memberships.
Yeah, I feel that I have definitely debugged the Go runtime more than I've actually written Go for sure, and it is a complicated runtime. Dave, you must also be feeling like, wait a minute, I'm working for a company that basically has Rust in its name. I mean, we're doing effectively. This is the old. I mean, we're using ClickHouse is in C++, the operating system kernel is in C, and CockroachDB is in Go.
Not just Go though. It's also 300 megabytes of C and C++ libraries.
Oh, interesting.
It is.
Interesting. Okay, so that
Well, this is a huge part of I think where our initial wheel spinning fear came from as well. Is that this? Well, I mean, we ported CockroachDB. It's not like it builds for illumos out of the box. So we add a bunch of patches to do that, and then unlike most Go software, it has some substantial native code stuff jammed in the side, which is not memory safe in the same way. So there's a lot going on in the process. It's a huge binary. It's hundreds of megs.
So Dave, there are a lot of usual suspects here. It sounds like big, complicated system, but one's also extremely important for us. So I mean, Dave, I know you were beginning to question, does this make sense to continue to debug? But I really felt like it did, because this is such a basic error that we seem to be seeing.
Yeah, I feel like I had individual conversations with you, Brian, and you, Adam, about this, and it's kind of this question of boy, this is pretty rare. Is this worth diving into? And we were like, well, but it is memory corruption, and it is the database.
Right.
So,
It is memory corruption that is going to be persisted forever, potentially corrupting everything. So you sort of put the stakes in those terms. You're like, maybe it's worth a little more investigation.
Yeah, and I kind of feel like this is how we know that our future selves have not invented time travel, because I feel we would have traveled back in time and slapped ourselves and just do not question this for a moment. This is because you just. I mean, and Adam, I think that certainly, Dave, you and I have made wish we had done more with Postgres in particular. I just feel I wish we had dug deeper earlier in our Odyssey with Postgres, and then maybe would have been in less pain when it was murdering us in production. So I mean, I think it was definitely felt like the right idea to dig into this, but it also, I'm sure, felt like, boy, I hope this turns out to be something that's relevant.
Yeah, it's definitely something I struggled with, not every single day, but seeing so many, all of my colleagues working on things that were very obviously urgent and important for the company, and I'm
Right.
off on the corner on this thing, making pretty much no visible progress for kind of a while on something that might turn out to be nothing, but like could be a really big deal. And given the nature of the bug in the end, I think it's pretty important that we did. Even if it hadn't been that serious, I think it would have been good that we confirmed it wasn't that serious. But it kind of is, right? I mean, this absolutely could have been causing database corruption.
Oh, this is, I mean, yeah, I guess we should get through the story, because this ended up being as serious as it could have possibly been, I think, more or less.
Yeah, that's pretty accurate. I hadn't actually thought of it that way. Like, what would be worse? Pretty bad.
It's pretty bad. It's pretty bad because I think that it is as bad as it could possibly be, in part because I felt that this was likely going to be confined to the Go runtime. And I don't know what your kind of gut was on that. And I mean, there's a level at which I guess it is, because the Go runtime definitely likes to push certain system facilities harder than others. But the root cause of this ended up being generic across, I mean, arbitrary runtimes for sure.
Yeah, and the impact is basically like anywhere in the program. Certainly in Go, anyway, as far as I can tell.
So
So
you want to start working back from the actual cause of failure, but you are also in a system that is pretty hard to understand and pretty opaque. So how did you proceed on that?
I mean, at some point, probably around that time, I think I had that conversation with Robert. I kind of bit the bullet, and I was like, "All right, I'm going to learn everything I can about this assertion failure and the data structures associated with it." So basically, the Go memory allocator. So I found some blog posts about it that were helpful. And then I just spent a while reading a lot of code so that I had a better working understanding, not necessarily like, fluency, even to be able to modify it with any confidence, but to be able to reason about what that assertion meant and why it was a problem that invariant was violated and how that could possibly happen.
Yeah,
And of course,
well,
go ahead.
that's a really interesting kind of the inflection point that you're describing, where I feel like you're going from I want this problem to go away to I'm going to understand everything about the Go memory allocator. Like, I'm going to understand everything about Go's GC. I mean, it just feels like you're taking a lot of agency over the problem, even though you actually don't have any guarantee that this understanding is going to actually give you any understanding necessarily into the problem. But I'm going to understand this system much, much better. That is what I can guarantee as I venture in here and being much more deliberate about it, which I think is actually important. Because I definitely go through that same inflection point where it's like, I just want this problem to go away, in that the realization of like, this is not going away. I actually need to attack it.
It's that step
Exactly
where
it.
you put down the other thing you're carrying so
Yes.
that you can use both hands.
That's
Like
right.
that's
That's right.
Yeah. Or maybe going from denial to acceptance or something like that. That's how it feels a little bit to me.
Well, it's not just that, but it's the blindness of the investment, right? Like as Brian was saying, and is often the case with debugging, right? You're almost never charging down the right path. You're charging down a path,
Yeah.
and the best you can do is kind of foreclose that path and have that kind of mindset. But we like to debug in environments where you can go exhaust some particular hypothesis and then pop back out and start on a new one. But this was one where real deep research was required.
Well, Adam, I like your phraseology too in terms of thinking of it as an investment, because the sure dividend from this investment is understanding of the Go runtime. That is what we're absolutely guaranteed going to get out of that. And I think you also have to come to grips with the fact, you have to accept that that dividend is actually valuable. We are relying on Cockroach as our system of record for the control plane. Understanding this thing better is a good use of time in the abstract.
Now, Dave, at this point, were you still running the full test suite, or because at some point you switched to looking at just running the Cockroach version command, which was also crashing like one time out of every 300, which was kind of astounding, right? It was at that point that you showed me that I thought, how is any of this working ever? Like, how is anyone running anything in Go or any of these Cockroach programs if it can't get out of bed to tell you what version it is?
Yeah, that's totally right. And obviously there's the common technique of trying to make simpler reproduction situations. And it was challenging with this because I had a bunch of different workloads that could reproduce it with sort of different properties. So Cockroach version would reproduce it, but it would take upwards of a day and like tens of thousands of iterations. And I eventually found that there was like a subset of the Omicron test suite that I could run that would reproduce it in about 3 minutes. So it would be like 6 iterations of that fraction of the test suite. So that was pretty reliable, but and much faster. But it was a lot harder to instrument because there was like a zillion things going on and like a bunch of different Cockroach processes in parallel and stuff like that. And then at some point, I think James was trying to dig into this and was wondering, like, does Go actually pass its own test suite on illumos, and ran that in a loop and found that produced a lot of the same failure modes. And so then there was like, that was another option on the table for, in principle, isolating more stuff, but there were some other complexities about trying to debug the problem in its own test suite. So figuring out what the right workload to use to debug this was also kind of tricky.
And then so in terms of the tactics, as you're understanding the way the runtime works and the GC works, the memory allocator works, one of the things that I love that you did along the way is effectively adding your own type definitions so you could print them out from post-mortem. You could print them out from the debugger. You want to describe that technique a little bit?
Yeah, totally. And this is another example of like, the problem is fractal about like wanting this thing to go away versus investing in it. Because I found myself wondering, like, it would be really nice if I could look at these data structures, but MDB, our debugger, doesn't know anything about them. I don't know what's involved in that. And then I kind of like put it off. And that question comes up enough times that I kind of wonder, like, well, wait a minute, how hard would it be to do this? And then at some point I remembered we had this typedef command within MDB that allows you to give it like a C code, essentially, that describes data structures and just teach it about a type that it doesn't otherwise know about. And so I just wrote some C structs that looked like the Go structs. I mean, one nice thing about Go is that there are some ways in which it's pretty simple, and this is one of those ways that it's pretty easy to figure out how that thing is going to look in memory. And so I was able to write a C definition for that. And then I was able to poke at those structures, and I was like, oh, geez, why didn't I do this a while ago? It's incredibly useful.
Well, and I think it gets to another one of those sure dividends when you are really investing in debugging is that tooling dividend and not just the gaining of understanding of the system, but hey, I'm building some tooling such that when we do have another problem here, we can do it faster and better.
Yeah, that's a good point. And a lot of that stuff I think is in the dwarf as well. And I know, we have had branches, I think, that haven't landed in illumos proper that would allow MDB to directly pull stuff out of the dwarf. So that might be another useful area of investigation that I think Robert knows a lot more about than I do.
Yeah, and I think, actually, to add to that, Dave, I think one thing that is satisfying for someone on the outside is like the : typedef is thing I added to debug stuff. I don't know. I feel like maybe almost a decade ago. But it's exciting to kind of see that stuff kind of come back and continue to pay dividends, just to the point of tools. Like, I did that to debug something. I honestly don't remember what. It was something in 2012. Maybe KVM. Something in KVM was broken.
Yeah, because you didn't have there's no CTF in the binaries at the time, right? You had to side load it in so that you could recover some of the debugging information you needed, I think.
No, CTF is.
There was something before that.
Yeah,
that
it was
was
QEMU, right? Like, it didn't have the
Well, that was when I traded. That's when I made the mistake of, well, not mistake, of
Yes.
trading you typedef -r for some Python code. But
God, that was
Yes.
delicious. That was what do we? Is that Robert's Folly? Is that Clulo's Gamble?
What is this story?
This was
I needed some Python code written to help deal with fixing some build-related issues, and Josh wanted the ability to read some. I think this is shortly after doing : typedef, which basically lets you phrase a C structure just in kind of, you basically type it out like you would in a C declaration, which is great until it gets painful. But then there's CTF, which has kind of auxiliary debugging information. And I said, hey, what if we just read that in from a file? And
An ELF file, critically.
ELF or just on its own. So just the CTF, raw CTF data.
Oh, okay.
But and at the time, there was definitely some Python thing. I needed to fix some build issues with how we were building stuff at Joyent.
The exception list thing. The exception list needed not to depend on Mercurial, so we could throw that out.
And my recollection of this was that you really did not want to write the Python and have to ramp up on that. And you two basically traded problems, and Josh was done with the Python in like 10 minutes. It's my recollection.
Yeah, because it was just it was a regex and deleting some stuff.
I thought it was the other way around, that I was done in basically like 15, 20 minutes, and then Josh was angry at me for a while.
It was,
It's possible that I was done in 10 minutes and angry for a while. Both. Like, that doesn't... I mean, 10 minutes of Python is still 10 minutes of Python.
Yeah, right.
So.
It can feel like years. So, but this very useful thing had been added years ago when Robert was debugging a problem. I should also add, Robert, the tab completion in the debugger is due to you, and I use tab completion all the time. Dave, I don't know if you're a big tab completion user in the debugger,
all the time.
But it's very nice when you want to print out in particular structures that it knows about. It's very nice to be able to tab complete them.
And credit for that is also due to
Matt Abner, right? You guys did that at a hackathon back in the day. So, so you're using this. This gives you kind of a higher level look, Dave, about what is actually happening. And are you beginning to kind of hone in on this thing at this point?
Oof. It was still a little ways. So I think this was a stepping stone to getting a dtrace script going that would then print out those similar, those same parts of the data structure, so that I could trace it. So that I could have data points from earlier in the program's execution to know when this thing was going badly. So we haven't really talked about the failure mode even, or the bug, but the failure mode of this thing was basically that you have this data structure, part of the Go runtime, that describes a block of memory that it's allocating objects from. And its bookkeeping in the data structure says that it's full, and then it's doing an assertion that the number of allocations from it equals the number of things that's in it, and it's not. So you get this block of memory that contains like 54 items, and it's full, but it's only allocated 27 things from it. And so the sort of obvious question is like, well, how many things were actually allocated from it? But in order to do that, you need the history of the allocations that came out of this span. And so I wanted a dtrace script that would trace all the allocations, and then also trace the GC sweep operations and show me what those that the allocation count was at all those points. So I could figure out, like, is this getting corrupted, or was it always wrong, or what the heck's going on, basically.
Well, and I think this is
Did that make sense?
Yeah, and it's a good example of something that we've used a lot. But I don't know if we've talked about as much, which is you are using, because now you've used postmortem debugging, you've used the kind of the symptoms from the failure to now formulate a question around runtime instrumentation. And now you're like changing to actually a pretty different tactic, where we're now going to instrument this thing as it runs, record a colossal amount of information, and then use that information as effectively a genie that can see in the arbitrary past when we fail again.
That's right. And the analysis that I wrote up in that bug is based on a combination of those, and both of those pieces were absolutely essential. Like, not just the postmortem that got us to the dynamic tracing, but also the actual data in the core file from the actual failure that we also had dynamic tracing from. It was all needed to figure out what was going on. And even then, it still took me a long time to actually understand what I was looking at.
Yeah, and I think it's a good kind of concrete example of how when you're stuck debugging a problem, sometimes just to back to that contact lens fallacy, or the streetlight fallacy, where you're looking for it, you're kind of using the information that you've got. You kind of want to step back. It's like, what is the information that I wish I had? And brainstorm on that a little bit. And then once you have your wish list of information that you don't have, then you can go solve that concrete problem of how do I go get that information that I wish I had, which you definitely did here.
Yeah, yeah, I think that's a really, really important point. It's sort of hammered home with the other stuff that we've been dealing with at work last week, where it's like asking yourself, what information do I wish I had? And then is there a way to get it? And it's not always easy. I mean, even once I had known exactly what I wanted, which was, somewhat hard to begin with, and knew how I could get it, say tracing these things with dtrace and teaching dtrace about these data structures and all this stuff. Then I ran in, then you have other problems like, well, is the amount of tracing going to chase the problem away to begin with? Or am I going to start running into drops because I need larger buffer size or faster switch rate because I'm just tracing too much stuff, basically. So it's sort of like continues to be hard. You know what I mean?
The thing I do love about that, though, is I just love it when a computer is doing work in my absence. You know what I mean? Where it's
Yeah, you've said that before. I think about that a lot too.
right?
It is pretty satisfying. It's satisfying to start the test suite overnight and come back in the morning. Here's the data you asked for.
It's like, well, I'm well rested. I've been sleeping, computer. Have you been? Yeah, it's very nice when you've got the. And then you also, again, kind of changing that disposition to I want this to go away to I'm attacking this. When you've seen it in that overnight run, it's really exciting. It's like, great, we saw it. I didn't chase it away, and maybe I've got the information now that I'm looking for.
Yeah, exactly. And then of course, when you find a new failure mode, that's disheartening. But
Yes. It's like, no, I'm not debugging you right now. What is this?
yeah, and that was another challenge with this was a lot of there were both false positives, like cases where like my stupid bash loop for running the test suite in a loop would fail, and so it stopped at 2 a.m. without having found a failure, and then also just new failure modes.
Those are the worst. When you feel that you've left something in a loop and realize that it like literally didn't make it through the first iteration of the loop, and the second you walked away from the keyboard, it stopped. You're like, oh, damn it.
So along these
Yeah.
lines, I found I really wished I had a tool that would basically run a command in a loop with no hub, then standard out and standard error to well-known places with and like record the environment, the working directory, get it all right. Because a lot of these things were super error prone, and I just kept getting them wrong. I'd be running the wrong cockroach binary and uninstrumented one or something like that. And does anyone know if this exists? I know GNU Parallel can sort of do this, but it's not. It's a little awkward, and I'm not sure it can quite do it. Or have other people run into this problem? I guess that's the other question.
So can you describe the problem again?
I'm like, so I have a case like this where I want to run a program until it fails, say. But I have standard out, I have standard error from it, and I want to keep maybe all the failures in this sort of organized way. So I want something that will basically just keep running it reliably and like also run under no hub. Like what I ended up cobbling together is this like, no hub, run this thing, redirect this thing to this file and that thing to that file, and the dtrace output to that file. And still you get all these false positives, and then you just have all this junk all over the place. And it was just like, it just felt like a mess. I want like run until this fails no matter what, and keep the output and put it here and let me know when it's failed or something like that. Does it make any sense?
I think you probably just need to write a program.
Yeah.
Well, yeah.
Totally makes sense, and I also understand why it doesn't exist, because like you need it and then you don't, and then
It's
by
a
the
pretty
time you need it again,
specific set of requirements too, I feel like.
One thing
I don't know. I feel like I've run into this a lot. Any kind of reproducible problem, but it's not reproducible every time.
I mean,
yeah, and it seems easy enough to write in the moment, and then you write it wrong 6 times.
So
that's exactly right. I wrote it wrong 100 times.
Dave, this does not solve your problem, but I had a similar kind of issue around a test where I actually needed to be able to be attached to a console, but no hubbed that effectively. I want to be attached to a TTY, but no hubbed. and this command dtac or detach, DTACH, which is one of these like commands that was just done a long time ago. It's been written, it's done. It was really, really valuable for debugging another issue that necessitated a reboot loop. But it's not wholly dissimilar to what you want, but it's not exact. This is more of a coming off of kind of these more like screen than running things. And you say like do parallel or whatever. So, did you feel there's that feeling when you're like, I'm definitely getting closer. I'm iterating in on this thing. Had that started at this point?
It had, but I was disappointed so many times along the way. I think that the most promising I thought I got that turned out to be just completely wrong was like 2 weeks ago. Andy Fitteman, also at Oxide, filed an illumos bug where in set context, we were not setting fsbase. I believe I can't remember if it was only on AMD or not, but we weren't setting fsbase in set context, which meant that if you called get context, and then so you're saving the current state of the thread to resume it later, presumably, and then you set context from a different thread, you would get the first thread's thread local data
Jesus.
in the second thread.
I
know, right?
I missed this book.
Which it must be said is not a common thing that people actually do. Like,
No, it's a really weird thing to do. It's a really weird thing to take a signal or to get context
and put it over here and use it
yourself
later.
And to then sort of teleport yourself into a different thread. We did look at that a bunch, Dave, and I think had some hypotheses about how that would manifest, and it didn't kick over anything that was a smoking gun, obviously.
I know that
That's
Go
right.
is the victim here, and it's unfair to blame Go. But Jesus Christ, do they push signals hard? They love signals.
Dave, you should talk about I can't even ever remember. You've told me a dozen times what signal they use to poke themselves.
It's SIGURG, SIGURG, which I believe is a signal. It's an old signal that means that there's urgent data waiting on a socket, I think. And so there's a whole comment in the source base, which I'm sure is sound. I didn't spend a lot of time thinking about it, about why they use that one, because it's like always available but not likely to be used because it's not that useful, because you don't know what socket the urgent data came in on, so it's like, okay, someone wants to talk to you urgently.
Well, and
and to some extent they have no choice except to use signals because that's what the platform gives you.
Yeah, if you want async preemption or you want like the thread equivalent of an IPI, signals is really all you have.
Yeah. Anyway.
Yeah, because the problem they're trying to solve is there's a Go routine on CPU.
Yeah.
Running Go code, and it's been running too long. We want to stop it running, and we don't want to rely on its cooperation. So I think with those constraints, I think you're kind of backed into a corner.
Yeah,
that said, like the Go people were the Unix people, so it's really, really, like signals are a Unix thing. So
yes,
feel like that is just the long shadow of that decision catching up with them.
So part of the reason I found that the fsbase bug compelling, though, is that first of all, it was found in Go. And Andy pointed me to a bug, I think it was in GCC Go from like 10 years ago. It was found in that on Solaris at the time. And I had spent a bunch of time in the allocator code being like, the bookkeeping here is just not that complicated, and I don't really see how it could go wrong unless there were multiple threads operating on the same thing without any kind of synchronization. That could definitely cause things to go weird, and that's about as specific as I got. And so I found this thing, and I was like, wow. And that explains, some of the system specificness of it, but obviously it was like completely wrong. Like it was just, nope, not at all that problem. And there were a couple of things like that where I kind of thought this was super promising. I also found sort of a meta thing here about Go. I'd always heard of Go as pretty, like compared to C, like pretty memory safe. But I found myself exploring all the ways in which there are all these rules about programming in Go that if you violate can cause basically arbitrarily bad memory corruption to happen. and like the pointer passing rules in particular, and the use of unsafe, and like if you cast an unsafe dot pointer to a U inputter, then the GC loses track of it. So if you don't have another reference to it, then that thing can just get cleaned up,
Yeah.
even though you actually are still using it. And so, I found bugs. I found a comment from someone saying the event port code is rife with these unsafe casts. And I was like, oh my God, it's got to be in here. There's got to be one of these that's responsible for us collecting some pointer too early, and then all hell breaks loose. And that turned out to be a total red herring too. So there were a bunch of times where I thought I was super close, but the time I thought it the most was last Tuesday, which is when I actually did end up nailing it. So, but I tried not to let my hopes get up because of all these times I thought I was close that were just nope, not even in the ballpark. Just something.
So what happened last Tuesday?
So Tuesday, I was chatting with Ben Necker about it, and I was describing one of the failure modes in some detail, and I was about to say something that I thought was true, that I realized wasn't true. And I was like, wait a minute, there's another explanation for how that could, this observation could have been true. So in particular, what I found, and I don't know if we want to get into super nitty details about it, but I think I can give a good summary quickly, which is that we have this data structure called the span that describes a bunch of memory that might be allocated, and there's these allocation bits. It's a bitmap that describes which sequential buffers in that thing are currently allocated. And so we've run into this failure mode where we think we have allocated all 54 of them, or I think it's 56 of them, but we've only actually allocated 27 things. And so I was like, well, how many are allocated? There's kind of a couple different ways to look at it. And I thought I'd look at the alloc bits, and they were exactly inverted from what you would expect. That is, the 0 bits were all the things that we actually had allocated.
Right.
And the other thing that was weird about that was, as far as I understood the code, there was no way that those things, the code doesn't actually set that bit when it allocates something. It actually only sets that bit when it goes and sweeps the span as part of GC, and it sets the bits to basically whatever it found as part of GC. So these bits should have been all 0, but instead they matched something that was so close to what they would have been if you had swept the span, except it was exactly inverted. And I was describing this to Ben, and I was like, wait, but if the bits, I don't remember if it was him or me actually, that if those bits were set that way before all this happened, that would explain the allocations. That was the key sort of insight about it. Was like, I had been assuming that these bits that were supposed to have been zeroed were corrupted at some point, or were being maintained correctly by a different code path I hadn't seen, and I didn't see how they were supposed to be inverted or whatever. It's like, no, they were just wrong to begin with, and it was a random wrongness, and that drove the weird allocation pattern.
And to be clear, what we expected them to be was 0. Like it was newly allocated, fresh from the allocator, all ostensibly be 0.
That's exactly right. Except that when I saw that they weren't, and that they matched that pattern, I was like, there must be some code path I haven't found that maintains them.
So
because what are the odds that it exactly matches the allocation pattern? But of course, they're 100% because it drove the allocation pattern.
Yeah, interesting. So in other words, it was the implicit assumption that zeroed memory had been zeroed was
That's right.
And so so this is interesting because one thing that you talk to a lot of different folks about this problem. I feel you did a very good job of, and I find this is another important tactic, is to talk to other people as you're stuck on a problem. Not only for the insight that they can offer, but also it forces you to repeat your own understanding of the problem, and allows you to potentially find a new way of thinking about it, just in the manner in the course of describing it.
Yeah, totally. And I mean, that's exactly what happened here. And I do wish I had done that a lot more along the way here. But I was also, as we were talking earlier, I had some doubt about whether it was a good thing to be spending a ton of time on, and I was reluctant to drag a lot of other people into this black hole that I might be in. So I was sort of trying to time bound it. I remember spending some time with you, Brian, and with you, Adam, and I got like an hour with like 10 different people, and that was very helpful. All of it was very helpful. Robert and Josh and Jordan and Ben. And then Sean put me in touch with a former colleague of his from Google who works on this area of the runtime, who was also baffled by this core file, which makes me feel better. I was like, can you imagine a situation in which we're allocating non-sequentially from one of these spans? And he was basically like, no, that's very strange.
That's vindicating. All right, so you've got the idea that like, wait a minute, maybe it's not zeroed initially, and then what did that allow you to do? That kind of that potential lead to go investigate.
Then it was kind of the standard, okay, I've got some corrupt memory somehow. Did it happen? Did something, I still was assuming at that point that something might have corrupted it. And so then the question is like, well, what does it look like? Does it look like ASCII? That might give you a clue about what had written over it. Is it a pointer to something else that's valid? Maybe you can find a subsystem that has scribbled over it. And it was neither ASCII nor a pointer. And then I grepped in the core file for that bit pattern, wondering like, does it appear anywhere else? And it appeared 2,000 times in the core file. And I was like, well, that's nuts, because this is an 8-byte bitmap that is supposed to represent what is allocated from this span. Like, why on earth would that be the same as any other 8-byte chunk of memory anywhere, ever?
I mean, that's like dropping the Kobayashi coffee cup kind of moment, right? I mean, that
Totally.
must have been really alarming.
Yes, yes, I was exactly, that was my reaction. I was like, oh my God, this is really significant. Still didn't really internalize what it meant, but I knew it was really significant. And I think that's the point where I was really hot on the path. And I was like, okay, where does this memory come from? It comes from this function. I'd heard something about in some, under some conditions on some systems, some registers that start with X or Y that I had never otherwise heard of aren't restored properly. And it was pretty quick after that point, I think, to get there.
And then, okay,
But
yeah. Well, so, and when you say there, we should describe what there is. But then, it feels like you're at that point, you have a promising and interesting hypothesis, but still a long way to go to connect it to all of the failure modes that you've seen.
Yeah. So then, I think so at that point, I was looking for where this chunk of bits comes from, and it either comes from having M-mapped anonymous memory or called some, which should be zeroed. And I trusted that, although I don't know why I trusted that, given what I later found. But there's a function that they use to essentially B0 a chunk of memory. This is a Go specific function in the Go runtime. That is like, at first I looked at it and I was like, wow, this is really complicated. I'm sure it's not this, so I guess it's fine. I looked at this like a couple months earlier and I was like, okay, whatever. But I took a closer look at it and I saw its use of these registers, and it had sort of clicked a couple or rung some bells with these failure modes. And I think at that point I asked Robert, is there some way to look at these registers in MDB? Because I couldn't find a way to do that. And at that point I had misread the code and thought it was using XMM15. That's actually for a different architecture that it uses that, different CPU features. And it was while we were looking at that, I was like, well, there's no way to print that, but do you also want the YMM registers, I think Robert said. And I was like, oh yeah, this code does talk about the YMM registers. Are we saving those? Is it possible we don't save those? And Robert, that's, I think, I don't know, Robert, what was your reaction when I asked that?
I'm trying to remember the kind of moment by moment reaction, but I think slowly getting to an increased sense of dread.
You were pretty sad when we talked about it, I assume within 8 hours of this conversation occurring. But I also feel like it wasn't like a lock yet. I feel like you were like, it could be this. I'm like, no, it's that. It's 100% that. Because Dave and I had talked about signal handling like a week earlier. And I think I had shown you the list of other signal handling bugs that I had been involved in. Also, I was surprised to find that the async preemption stuff was turned on at all.
Yes.
Given
that was what you conveyed to me in that conversation.
Because there was like Go community skepticism that was going to be sound on any platform other than Linux.
Huh.
And like I vaguely remember like reading some message from possibly even Russ Cox about that not being turned on. But that must have been years ago at this point. So I guess it's probably on everywhere now. But certainly when you turned it off, it was not reproducible, right?
That's true. And I deprioritized that data point because it looked like a concurrency bug. So I didn't know how much that was just because the ordering of things.
I think so. I think you're
Well,
right to
'cause
deprioritize
when we-
that. I mean,
when we-
'cause I think it's like
When we spoke about the signals, though, you were worried about the other thing, the unsafety thing, where if you put a Go pointer in C memory or something,
Yeah,
it can get confused.
yeah. The rules around when you can, like, what pointers you can store in what parts of memory. Like, can you pass a Go pointer to C memory? I think the answer is yes, as long as there are other Go pointers pointed to by that Go memory. Yeah, there's a lot.
We put a bunch of stuff on the stack between when the kernel vectors for a signal and when we get to the Go signal handler. Like, we do our own stack frames, which is unusual for other platforms. Mostly their signal handling machinery is, I think, entirely in the kernel generally, whereas a decent chunk of ours is actually in libc.
Gosh, I loved your summary. At the very beginning of the conversation, you were like, I'm sure we're not doing anything unsound, but I'm sure we're doing things that Go is not expecting, or something like that.
Yeah.
This was the whole avenue of investigation. It didn't cover it in the bug report, but it's like there's a lot of ways that could have gone wrong, but turned out not to be that. But
But I think
yeah.
you were right to minimize the data point of like, okay, so if I change this other big flag, if we run with this other different effectively configuration around not having async preemption, I don't see it. Hard to know what to do with that. It kind of is like, okay, I don't see this if I have fewer CPUs enabled. It's like, well, all right.
Right.
We just gonna like ship with fewer CPUs. I mean, it's like at some point, like you have to actually understand the problem. So I think it was like you're wise to just like I'm gonna file that away as a data point, and we'll see. That's it. We'll see if when we get to the end of this thing, that data point ends up being relevant. I mean, it did. It helped bolster, I think, the findings.
Yeah, and that is basically how I ended up using it. And Michael from Google had also said that Linux had a similar sounding bug. I don't know if the failure modes were quite the same, but they had a similar situation where under some conditions, I think it was like if the first page of the signal stack was not faulted in, then YMM was not preserved across the signal handler. And it had been very hard to debug, is what he had said. So that was another thing that probably was what kind of put it in my mind that, once I got to the code that was using these registers, thinking like, oh, that could be a similar bug going on here. But directly, it didn't seem super useful. I mean, maybe I should. That's why I was saying at the beginning, like, arguably, I could have gone down that path a lot earlier, but it did seem so hard to know what to do directly.
Yeah,
with that.
I feel that you were wise to. I mean, I think you got to go to the problem and debug the problem. I think, and as opposed to, because I mean, I think that's kind of in the category of like making it go away, and it's like, not that there can be utility in that, especially when you're bisecting a problem, but when you've hit a big switch to completely change a program's behavior, it's very hard to conclude much from that.
Yeah, and I did kind of feel like if I follow the data and just keep going, I should eventually get there anyway, right? Like it's not wrong to follow the data that I have.
Yeah, and so you got this very interesting hypothesis. How did you explore? Because I actually love the descript that you wrote in here to actually hit this a little bit harder.
You mean when I tried to reproduce it? Yeah. Well, so before I did that, I think I wrote a C program to test this by just having main write to YMM0 and then a signal handler under certain conditions would whack it and then see what happened in main if we took a signal at that point. Oh, and I did use a descript at that point to raise a signal at exactly the right moment.
Yes.
And saw that, yes, indeed, we are not saving, we're not preserving this correctly. And it was about in parallel with that Robert confirmed by looking at the code that it didn't seem like we were saving that correctly.
Which, Robert, you may have had dread about, but I was elated. I mean, that's great. This is great news.
It's the best possible outcome.
It's terrific.
So we can fix it. We can fix it, and we don't have to like take a patch to another consolidation to do so.
Yeah, we don't need to convince anyone that they need to fix a thing that they claim doesn't exist except for in us and so forth. I mean, it sucks that like we got it wrong, but it's great that it's right in our hands. Having
had the mirror image version of that problem, where it's like definitely someone else's problem to fix, and they won't. Like it's
much better.
This is better.
Yeah. Yes. Then how did you?
So then I tried to reproduce the very problem, and this is Brian. You've described the sort of walk-off home run feeling you get when you think you understand a problem and you trigger it, knowing this. So something that's been very hard to reproduce, but knowing now what you think the problem is, you try to trigger it very precisely, and you trigger exactly that failure, and how exciting and awesome that is when that happens. Like really hoping for that here, because I was like, well, I can raise a signal at exactly the point in this function, in the very call path that I think is causing this problem.
I got bases loaded.
And it should blow
bases loaded, bottom of the ninth, right guy, right spot.
Right.
And
yeah, Casey has struck out. It basically didn't reproduce. It was more readily reproducible, but not enough to really be that satisfying. So Cockroach version, I would see, like I said, it could take tens of thousands of iterations, and with this enabled, it would take I had this descript that would raise a signal at exactly the right moment in the right call path. It would reproduce it after 30 iterations, which is way better. And you could have done some statistics to convince yourself that I really was making a difference, but it was also 29 times in a row that it didn't reproduce it. I was not feeling as good about it as I wanted to. But then I broadened the descript so that it would just raise a signal every time in this function that's basically their B0. Right after they initialize YMM0 to 0, I would raise a signal. And 50% of the time the program would die, and most of the failures were a totally different failure mode that I hadn't seen before. It was exactly the sort of thing you would expect. It's you tried to initialize something that was already initialized. It's yeah, well, that definitely could cause that if you B0'd something and now it wasn't zero.
You said that raise is a destructive detrace action, destructive in that it changes the state of the system. Adam, you added raise way back in the day. Did you?
I love raise.
It is. It's one of those things, man. When you need it, it is really, really nice.
There's a Turing completeness like property that the system has because of raise. There's all kinds of things that dtrace doesn't do by itself, but because you have raise sig stop.
Yes.
You can implement them later as bolt-ons, basically. But if you didn't have raise, then you would not have been able to do almost any of those things.
Also instruction tracing, which if I'd ever used before, it was very, very rarely. People know the PID provider traces entry and return to every function in userland. I mean, you can pick whatever functions you want, instrument, entry, and return, but it's pretty rare that I've instrumented individual instructions. But that was necessary here, and it's
this is good.
Oh, that's cool, dude. I didn't know you used that there. Yeah, both facilities made 20 years ago, and I don't know with a particular goal in mind. Often we build pieces of dtrace based on the problem we were actually trying to solve. But with instruction tracing, it was sort of well, we can do this too. Should we do it too? And it was sure, let's do it too. And Brian, I don't think there was a precipitating use case for raise other than it being nifty.
Well, it's pretty nifty.
There we go. Nifty it is.
I feel like I've used it.
It's very helpful.
And I used the instruction.
Yeah, the instruction tracing I feel is not actually that well. The fact that you can trace an arbitrary instruction it's again one of those things that, boy, when you need it, you really need it. And Adam, I remember you instrumenting every instruction in Firebird.
Yeah. No, in fact, in the early days of writing the PID provider, I would instrument every instruction because that didn't work.
Definitely did not work.
And I think that people run into that facility more often than not by accident because they go to
with wildcards.
Well, they try to instrument, every entry and return, but just leave off the entry and return. So instead of getting a million probes, they get a billion probes, and it takes a little bit longer to create those, and runs the system out of memory and stuff like that.
But it was load bearing in this case, Dave.
Yeah, and I had also used it earlier in one of the first descripts that I used to get more instrumentation from this failure mode. I really wanted to trace when GC was freeing a pointer, but there's a function call in Go, but it was inlined, so it was in the middle of a sweep function. So, but fortunately, that was easy to find and trace. And then I was able to grab the arguments, what would have been the argument to that function, obviously sitting in some register. This is definitely like, it's not that exotic, I guess, but I hadn't really done a lot of this. Like, oh, I'm going to instrument this inline function and print its argument out of this register.
So Dave, I think this maybe gets to something you had alluded to in a conversation with me, talking about like dwarf integration. To be able to say, trace this function that doesn't technically exist anymore and trace its arguments, which aren't where you expect them to be. But that kind of integration, it's not something we ever got to, but I think Robert's certainly built some bridges in that direction.
And it's super important for Rust, where the
Oh my goodness,
What-
yes, where everything is one
everything's
function, right?
The whole program is one
and,
big
and
function.
it's like, and you also you want, I mean, for good reason. I mean, it actually you end up with a much higher performing artifact as a result. So you really do want to. That's a challenge. And rampant inlining is a huge challenge. And it's like nested inlining, and it's gnarly because you're trying to kind of reconnecting the binary to the code that the programmer thought that they wrote can be a real challenge.
Yeah, I have. There's actually. I don't think it's too bad to go do. Just need some time. But we already have prototypes where we can transform the dwarf unwinding information into D. So that actually is a way to get at all the local variables in that context. And then from there, I already have, at least in my head, sketched out what basically, instead of trying to do a paid provider based on the instructions that you have there, doing that based on the source. So basically being able to specify this file line and then like offset in the line.
Yeah, that'd be good.
And getting that to transform into like the entry and return, they forgot some of the probe name spacing, but I think that could lead to a pretty useful way to phrase that, because then you can go and say, here's what I want to instrument logically in this source code over here, and here's how it transforms to that, and then here's, because for better or for worse, Rust takes advantage of the fact that it doesn't use a standard API, so you kind of have to rely on Dwarf to get access to arguments and other things. But then with those two combined, I think you get something pretty interesting, presuming you have
Dwarf. And the Dwarf, thankfully, the Dwarf really is complete for Rust, which is, I mean, God.
I think it's pretty complete for
That's great.
Go.
Yeah, it's great.
As
Yeah,
well,
no, that's
actually,
terrific.
like despite hesitance, I think, to use debuggers, perhaps they do actually have the information in there, at least for like some kind of reflection thing, I think. So
I don't.
Thank God
they're
for
not-
that, and also for frame pointers, and also a reasonably standard calling convention.
they're
Yes.
not terribly against the idea of debuggers for what it's worth. But what that actually raises an interesting point, which I think is that one of the fascinating things in this entire Odyssey was the primacy of the use of tooling. And I think we've kind of alluded to that, but not stated it directly. But without proper tooling, I think this would have been an incredibly difficult thing to go and figure out and solve.
It's a great point, Dave. And you're also talking, Dan, but you're also talking about Dave, who is an expert in this tooling, who is also learning more about this tooling motivated by this bug. And that's one of the remarkable things that, Dave, you're kind of phoning a friend with 7 or 8 colleagues. And each of them was not just teaching you about a different part of the system, a system that you're very familiar with, but also like instructing your use of these tools that you're also very familiar with.
Rep, baby.
Totally.
I feel like we all have like a desk drawer full of
In your
Lengths of
like
wire.
I was saying,
terrible
right.
lengths of wire that we have acquired during like past periods of discomfort.
But that's
So you kind of just
qualitatively
you're surveying like can you give me your wire drawer and your wire drawer, and it's definitely it helps.
A thing that's interesting, though, is that that's qualitatively different than some of the recent social media flexes you've seen with people being like, I don't use debuggers because I don't need to. It's like, well, that's a bit more of a cell phone than you
That's right.
perhaps realize.
Yes, absolutely. And what I think also, Dan, I mean, when you're especially around like the double E's, where it's not like a position where you're like, I think we should use a scope for this, or I think we should use a logic analyzer. It's like, no, these things are like undebuggable without the tooling. So the tooling is really, really, really important, and certainly was essential for this problem. So yeah,
Brian, I think it goes back to your point about focusing on what question you wish you had the answer to, instead of the questions that are just easy to answer, because those might not be that informative. And then you have to end up doing this tortuous logic to figure out what it means you had some piece of data from something that was easy to collect, but it's not clear what it means, but you can kind of maybe try to infer what it means, and you just get twisted in knots.
Yeah, and then so how did you? Because I love the tactic that you used once you really could hone in on this thing to show that this was the same problem.
Well, this is where so I had first tried what we talked about of raising a signal at the right moment and seeing if the same problem happened, and I couldn't get that line of approaches to really give me the satisfaction I wanted that I had solved this problem. So what I figured as well, and there was also this question of, well, even if it did, it doesn't mean, I started off saying I ran the test suite in a loop and found a million different problems, but they don't necessarily all have to be the same problem. There could have been a lot of problems here. So I said, well, what if we fixed this? If I had a binary that was exactly the same except used the XM, basically didn't use the registers that we didn't preserve. This function has a bunch of different modes depending on what's available on the CPU in terms of registers and instructions. And so you can tell it, well, you can't tell it, but with enough force, you can tell it to use whatever mode you want. And I figured if I can get this thing to not use those instructions and then see how long the test suite runs without having a problem. And if it's, remember, this was reliably reproducing after like 3 minutes on my machine. So if it goes kind of a while, then I think we can have good confidence that this is the problem and the only problem. And I thought about building doing a new build, first of the Go runtime and then of Cockroach using that Go runtime. But I was worried that there would be some other, I would still have some doubt that there was some other factor. So so I was like, well, I was just going to patch the binary, which I also had never done before and did not know the MDB operator for doing that. Thanks to Keith for that one. And so I
may have used that one a
bit. There's this step in the function that checks a bit that Go has previously set based on CPU ID and I forget the xset BV or whatever the other xget BV, the other thing that tells what the OS supports. So it does this early in startup and then sets a bit and then checks it in this function. And if that bit is non-zero, then it jumps to a place where it uses those registers. And so I just knocked out the jump so that it would go straight to the XMM code. And so it was like a very small targeted change to the binary that had a pretty well understood impact on the code. And sure enough, that thing ran for hours and hours. It ended up dying on a different problem, which I've since worked around, and now I'm running it again, and it's been running for almost 48 hours without an issue. So I'm feeling pretty good about. There's not something else horrible lurking here.
That's great. So
I guess I shouldn't say that out loud, but
I think it may be worth Robert talking a little bit about the because the fix is somewhat complicated, and I would also say that one, Dave, you saw that this was a bug that had been seen in many different forms, had many different manifestations. Interestingly, not just on us, on other operating systems as well. I would dare say that we are not the only operating system that has had this particular pathology, which I thought was really interesting.
Yeah, well, there's a couple of things there. One is that the specific messages for this failure mode have definitely been seen a lot. Like if you search for them, you see them in the Go issue tracker, and not all of them have been resolved. So one of the questions I had was like, is this actually illumos specific? I don't know. Like it kind of seems like it is, but then you wouldn't expect to see all these bugs with it open. But and then the specific problem, like underlying cause, also seems to have happened at least on Linux and possibly on other systems.
And
well, and as you see, Brian, like on its face, it sounds like a simple problem. Like you weren't saving some registers, and so save those registers. Like, what's your problem? But it turns out to be much more complicated than that, and an interesting history just of how much state there is to save. And there seems to have been some cat and mouse game that people constantly fall behind on in terms of CPUs having more and more state to save and operating systems forgetting.
Interesting history and future too, because I think this is a problem that's getting harder for the operating system, not easier. So, Robert, do you want to give some context there? Because it's a pretty interesting problem.
Sure. Yeah. So I think as we've kind of talked about the main issues that when you take a signal, and this is kind of goes back to, I think this is a System 5-ism, on the signal stack and these get context and set context routines, was that you could kind of know all the registers that were there and modify their state. So the challenge is not that you can just use signal handling just to like handle the signal and like move on with life, but you can actually change the interrupted state that gets returned to. So that kind of starts to bake all of these structures into the ABI of all these systems, whether it's Linux, BSD, us, someone else, that's all in there. And people, it's not super common, but people will do this to like change the actual register state around and to change, hey, like I got this signal, you can even think of the classic JVM, like we got a SIG-SEG-V and we need to change, where's RIP, stop executing that and jump somewhere else. I don't know that they actually do that internally anymore, but like that's like kind of the origin of like what people do with signals and why you have all this register state visible in the context. And unfortunately, on AMD 64, the original state was this FX save state, which is 512 bytes of XMM state and the 83, 87 floating point stack and all those fun things that you have. But then when Intel introduced the YMM or AVX instruction set in Sandy Bridge, then that state starts to explode, and state keeps getting added. So with AVX 512, all of a sudden now you have 2K of register state because you have 32 512-bit registers. Then Intel's matrix operations, which they're adding in Sapphire, are like 8K of register state. And the semantics of signal handlers are that you have your own register context to do whatever you want. So there's a lot of, even if you just ignore the problem of the ABI and try to make sure you don't break anyone who's expecting to modify this, even though the floating point state hasn't been modified too much. The bigger challenge these days is actually just not overflowing someone's signal stack.
Right.
Everyone for a long time said, hey, use a 2K signal stack. Right. That's great. You'll be fine. And now the actual state that someone needs to spill is over 2K.
And then you also need you want to not spill those registers if they are not in use. So you've got complexity there. And then you also have vulnerabilities where that attribute is effectively being exploited in speculative or side channel attacks.
Yeah, so it's solving it well is kind of nuanced, and I think actually AMX, which is forthcoming, makes an interesting trend where it will be the first unit not to be enabled by default in a long time. And that application actually have to opt in to using it, because all of a sudden imagine every time you're switching threads, you're paying for 8K of B copy there, or they just want people to promise that, like, yes, my signal stack will be able to support you spilling 10 16K onto it when I take a signal. So and I think in the matrix, the Intel's AMX is a whole bunch of matrix tiles that are like 1K each, so I don't think you're going to see that in a lot of general purpose computing per se, at least.
And I think we can fully expect this as GPUs and CPUs continue to converge, which I think is not an unreasonable kind of prognostication. Certainly Intel and AMD want to do that. We can expect this problem to get actually gnarlier, because you're going to have these registers that are designed for kind of one type of software, but in your case, Dave, with the B0, they're being used for a different kind of software. It's like, well, actually, it's a register, and I'm not going to use the floating point aspect of it. I'm going to use it as a register to be able to stage in and out of RAM or what have you.
I do wonder if, because we virtualize all these registers today, ultimately, right? This signal handling mechanism is part of, like, the saving and restoring and switching from thread to thread is all like in an attempt to give you the appearance that nothing has happened, and that the registers is just yours, and they're just regular registers. But like if this gets up to being like a meg of, random accelerator crap, basically. Like, I don't know that
Lies will continue.
spilling
The
into
lies
the
will
stack
continue.
that way is
Continue the lies.
like, it just doesn't seem, it's like, at least with the GPU right now, right? Like, it's a separate resource that is managed apart from the LWP, which like has some benefits, I think. I don't know.
So, Dave, when you did you get that walk-off home run feeling? I mean, you must have certainly through this whole thing, but was there a single moment that gave you that kind of primal feeling?
I think the closest like discrete moment was the C program that showed that we were not preserving YMM. I was like, that definitely. I mean, because that can explain everything. Nothing up to that point could explain all the data that I had, and that really could. And actually, like something a lot like it had to explain it. So that felt pretty
Well,
good.
it must have also felt great to have so many of these different manifestations cleaned up by the same problem. And because you're thinking like, I mean,
Yeah.
these presentations are not necessarily all that similar. I mean, some of them are similar, but there's a lot. I mean, of course, in hindsight now, it's like, yes, when you scramble someone's registers, there will be lots of different kinds of failure modes.
Yeah, totally. The three that I ended up focusing the most on were all in the Go memory subsystem, and the one we've been talking about was this case where it blew an assertion thinking the thing was full when it was only like half allocated. And that one, you kind of had to get further unlucky after hitting this problem in order to hit it, because you had to have reached the point where it would do this assertion, which it wouldn't normally do. If it did a GC sweep before then, you might hit one of the other failure modes, and that's why you'd sometimes get more than one failure mode. And there's a third failure mode that would happen during sweep, depending exactly on what the state of that thing was and exactly how it was corrupted, basically. Then we also had some segvs. We had this port getend returning with apparently impossible errno. We've also had a couple of cockroach bugs that were, the cockroach folks were like, this can't happen. This is like memory corruption of the worst kind. And at the time we're like, okay, well, not our highest problem right now. But like now looking back on that, I think we can say this could have certainly caused that. Right?
Yes, and I mean, I would go one stronger in that left unfixed, this would have had manifestations for us in production.
Yes, I think that's right. I think it probably
calamitous ones. Absolutely right.
The
And
OS 1028 of databases.
God,
yeah, because we've seen things where, again, I haven't gone back and checked that all of these are explainable by this problem, although it's hard to imagine a problem that couldn't be explained by this problem, given, P0 isn't zeroing. But we've had like a bunch of stuff where you're just like doing a select from cockroach and it's like, I blew my own internal unique index on ID trying to insert an ID into this table.
What?
And you're like, what? That's like, that error message doesn't even have anything to do with what I asked you to do. You know what I mean? But it's like very deep inside Cockroach being confused. We've had a couple of things like that already. Like, yeah, there's no way to me that none of these were caused by this problem, and we weren't going to have a serious problem in production because of it.
And a problem that would have been without any guarantee of reproducibility. And when Josh is making reference to a really gnarly bug we had years ago, where we had memory corruption, a kernel memory corruption issue, where we would die in like wildly different manifestations. And we, in a smaller number of cases, that data corruption actually, it was ZFS that was the target of that data corruption. ZFS was absolutely a victim. This is not a ZFS bug at all. But the data corruption ended up then being on a metaslab on disk. And that's the gift that keeps on giving. And now you've fixed the actual data corruption. And we absolutely, Dave, it's very easy. I can imagine that we could have had this issue where we ended up being corrupt on disk.
Yeah, and even if you did know exactly what it was, how would you know which of the pages of the database were corrupt? How would you know what was supposed to be zeros? How would we fix it? How would we even assess the blast radius?
So, yeah.
I mean, what I think happens is you ultimately end up closing hundreds of bugs later with, it was probably this.
Oh, sure, but I mean, what do we do with the production system that seems to have hit this?
Apologize. I mean, there's really nothing else you can do, right? The data is gone. Like the right
Well,
data
but
is not there.
especially when you got data corruption, you have these effectively these failure modes that are wild, that are completely outside of the bounds of the system, and are non-reproducible, as data corruption often is. It is wholly dissatisfying to not get that completely debugged, because you know that that thing is lurking out there for you under presumably a less presentable future failure mode. So, Dave, I mean, I know this took a long, I mean, this was heroic effort on your part to keep grinding on this. Because I feel also like if you had stepped away from this, no one would have faulted you for it. It would have been understandable for you to be like, look, we've got other things to do, and, you know, but I'm really glad that you stayed at it.
Yeah, here. It's got to be so vindicating, not only to solve it, but to solve it in a way that shows just how damaging it could have been. Because I don't think we recognized specifically that. Like we had some intuition that this could be real bad. But now that you've determined the actual problem, it could have been real bad.
And well, in particular, just as I said earlier, Adam, I did not think that this was going to be an issue beyond Go itself. I felt like the odds of this being an issue with the Go on illumos, on Helios, like that felt like definitely plausible, maybe likely. Although, as you say, I mean, Dave, the thing that's interesting is like this failure mode has been seen on lots of other systems. Like we are not and I think even on the ticket, someone had pointed you to a Linux bug that this was that the symptoms were very reminiscent of, and on some other systems where you don't necessarily have someone digging all the way into this, you do wonder if these other issues aren't lurking out there.
Yeah, totally. I mean, certainly in retrospect, time well spent. Kind of did it.
Very, very, very glad. And did you, any other kind of higher order bits coming out of it? I mean, obviously, glad that you spent the time. That felt very vindicating. Were there other lessons coming out of it?
I'm like,
Other than saving the company and our customers from data corruption, is that what you're saying, Dave?
Brian, but other than that, okay. Also, I just think that, like, I mean, not to put words in your mouth, but I think that that conversation with Robert, where you began to really attack the actual manifestations of the problem, I think that was an important inflection point on this.
Yes, very much, totally. And there's another thing that I haven't figured out how to distill it, but I just ran into so many mini problems along the way. We talked about a couple of these, but like, I wanted to search the address space for something, and this bit pattern, and we have this ugrep command for that, but it doesn't work if libumem isn't loaded. And so Adam gave me an incantation that will basically like dump all of it to a text file, and then I can grab that, which is fine. I mean, it's good. There's just like so many things. Another example is I wanted to try to reproduce this on AMD in AWS, because at one point I was like, is this my machine? Like, is memory bits of memory being flipped in my machine? I'll just like provision an AWS machine, but I couldn't because we had some trouble with the newer AMD instances in AWS. And so there's like a meta point here around like deciding that it's important enough that you're going to keep going, even though there's all these things, which is hard when, as Adam, you said, you're like, I don't know what the probability is that this path is going to be that important. Like, I want to grep this address space, but like, I don't know if this is really that important that I'm going to spend the time to. That one's not that time consuming, but there were just a lot of other stuff. Or like teaching MDB about the Go structures. It's like, I want to print this. How badly do I want to print this? For a while, I was like, not badly enough. And then eventually I was like, okay, I'm going to figure out how to do this.
Dave, there's so much that people can learn from your experience here. And I think that if they take away nothing else, it's just the level of detail that you put into the write-up.
Really good.
Because it's that artifact that lets everyone benefit from this experience. And to some degree, I mean, obviously diagnosing and fixing the bug is hugely beneficial. But the write-up that you did just carries it beyond that, because like you're going to influence folks on the team, folks on the podcast, but then just folks in the world who want to have that joy of debugging and discover that, and that artifact really
Totally.
helps them along.
Yeah, I was thinking back to Lukeman. We had the terrific episode. What was it in the earlier in the year, Adam, with Lukeman and Jordan on their write-ups, and I just think it's so important. It's so important pedagogically, but also, Dave, it's important to kind of for your own thinking, I'm sure. But I loved seeing all of the techniques and the different techniques. I mean, Dave, you described this as a bingo card at one point. And it really does feel like you've got blackout on the debugging bingo card.
Yeah, I definitely felt like I pulled out everything I knew on at one point or another. And yeah, I think the write-up's really important. And part of it is because I feel like I invested all this time, like we've got to be able to leverage that somehow. So I want this information to be available, not just like if people see a similar problem in the future or if people are wondering like how do I do this particular thing. But also for myself looking back, every time I've looked back at a bug that I've written an analysis for, no matter how detailed I thought I was, there's always stuff that I wish that I had put in. I'm like, wait, I know there was something else here that I've forgotten that I didn't write down. And so my write-ups have gotten longer and longer, but I just feel like it's a way to make that time
Totally.
pay off.
And I think I do think that the bit that is that, and I think we've gotten into it here, the despair of when you are not actually feeling like you're making progress on it is something that, I mean, problems worthy of attack prove their worth by fighting back, right? The Piet Hein line. And I feel like this one fought back a lot. This one was definitely was heading you off at every corner. Yeah. And I think it's easy for, it's hard to persist on a problem when you have despair. It's really hard. But they're hard problems because of that. That's what makes them hard.
Yeah,
But
absolutely.
you remember the XHCI despair? That's definitely that was a source of despair.
There's another sort of benefit to doing a write-up with this level of detail, which is it's a little bit, I guess, soft is the way one might describe it, but it helps set a culture that says, hey, it's okay to attack really hard problems. And it is okay to sort of go down into the well of despair and be like, oh my God, I'm not making any progress. What is going to happen here? That is something that I think that we encourage at Oxide. We encourage the development of tooling. And Brian, as you've said several times, it's never time that's wasted. It's always time well spent. And I've been in lots of other organizations where people are like, that's not important, don't do that. And that's, I think if you have these artifacts that people can look at and say, oh, hey, look, they took all this time and really ran this down to ground and figured it out and found this actually really pretty severe bug in the operating system that could have been really bad.
Yeah, you make a good point. And hopefully, and this is the advantage of it being open source and everything being out there. Hopefully if someone saw a different environment, different operating system, different programming environment, but saw a problem that only reproduced under certain conditions under a test run or what have you, but was disconcerting and wanted to be able to investigate it, to be able to point to this kind of Odyssey and say, hey, this can be really, really important. And my big belief is that these things may be giving you your last opportunity to really debug it. And the next time it may be in the field, it may be with a corrupt database, it may be much more difficult to debug. So seize those opportunities when you got them, which Dave, you definitely did on this one. Great work. Really, really, really good work. I'm sure it must have been a huge relief.
Thanks. Yeah.
Yeah, and it was a village too. It was a lot, obviously Robert, playing a kind of a clutch role at the end, and Keith and everyone else along the way, giving you Adam and everyone else helping you out. So
totally.
Good stuff. Great debugging yarn. So, well, Dave, thanks again for joining us. Really, really appreciate it. Yeah, this is
thanks
great.
for having me.
We are so Adam. What are we thinking about for next week? Are we?
I don't know if we have a topic, but I think we said that we were going to do it.
So we're going to do it next week, and then not the week after. Not on. So we will do it the day after Christmas, but not the day after New Year's, effectively, because I think you're out, right? And then we got predictions the next week. I feel we may want to do some looking back of our predictions from 2022.
Oh yeah, for sure. For sure. We're gonna have a little bit of a clip show on that one for sure.
Have you re-listened to the predictions episode recently?
No, I haven't.
Yes.
Have you?
And you are your Web3 prediction is really, really good. I felt.
I think I did go back and I looked at the show notes on that.
No,
and
you
I
should feel
actually
good about that
figured
one. It totally reminds me of my iPhone prediction. This prediction that was very correct, but also very wrong in that I was dismissing my own prediction. You were like, I think no one is going to even talk about Web3. It's going to be a term that people haven't remembered. But I also, this is my heart, not my head, making this prediction. It's like, all right, Adam's heart nailed it. All right, so we'll see everyone next week. And have a great holiday. We'll see you in a week.
And Dave, last depressing thought that the next time there is a Go memory subsystem bug, unfortunately, you're going to be the one I turn to.
Call me up.
All right. Thanks, everyone. Great work, Dave.